Hi, so today in this video we're going to be talking about finding missing sides of right triangles. We're going to be using what is called here SOHCAHTOA. So that is, whether you know it or not, the things that we learned yesterday. So this is just kind of like a little nonsense word phrase here, SOHCAHTOA, that helps you remember what our ratios are for sine, cosine, and tangent. So the S here is sine, the C is cosine, and the T is tangent. And then OH, that's going to be the opposite over the hypotenuse. So remember, sine of an angle. And I'm going to put a little circle with a line through it. This is a an abbreviation, I guess, no, like a variable for an angle that's missing. It's called theta. So it's not a 0, it's a little Greek letter that's a circle with a line through it. And so if you're looking to put a variable in for a missing angle, oftentimes we use theta. Okay, so sine of an angle is going to be equal to the opposite side over the hypotenuse. So that's what this first part is reminding us of. Sine is opposite over hypotenuse. Likewise, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so our objective today, we want to set up our trig ratios to help us find missing sides in a right triangle. So let's go ahead and get started. We'll try an example. So here we want to find the length of side AB. We know that the hypotenuse is 12 centimeters long, and we know that this angle in here is 25 degrees. So because we know this angle right here, and we're looking for this side across from it, I'm going to use 25 as my reference angle. Now, if I really wanted to, I could find this other angle, right? Because I know 2 of the 3 angles in the triangle. But let's just go with what we have. So we have this 25-degree angle. So I need to figure out which one of my functions, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So because this is my reference angle, this side over here is the opposite side. And the reason I care about that one is because that's the one I'm looking for. And then the other one I know is the hypotenuse. So I want to choose which one of my functions, sine, cosine, or tangent, uses those two sides. Which one uses opposite and hypotenuse. And that would be sine. So in this one I want to use the sine function. So I'm going to say sine of my angle. So remember the angle is 25. The angle always goes right next to sine or cosine or tangent. So sine of 25 degrees should equal the opposite side. The opposite side is x over the hypotenuse, and the hypotenuse is 12. So I don't know why my marker is so frustrating, but sine of 25 equals x over 12. I'm rewriting it just because I can't really read the one above. And sine of 25, if I put that in my calculator, I'm just going to get a number, right? So I can't like get 25 away from sine by dividing or something. This is a function, it's a relationship that this angle has with the side length. So what I want to do here is I want to get x all by itself. And because x is divided by 12 right now, I need to multiply both sides by 12. Now when I multiply this side by 12, I have to be a little bit careful. I need to multiply the entire function by 12, but I am not multiplying this 25 by 12. Okay, this 25 is inside the sine function, and this 12 is coming over. It's multiplied by the entire thing. It's not multiplied by that piece that's inside sine. Okay, so in my calculator now, I can find what x is equal to by doing 12 times sine 25. Now, if you put that in the other order, if you write x equals sine 25 times 12, you can do that, but just make sure that you close that parenthesis on sine before you try to multiply it by 12. And again, make sure your calculator is in degree mode. So I'm going to go ahead and enter this in my calculator, 12 times sine 25, and that gives me 5.07. So I'm in centimeters, so I know this is going to be centimeters. So this side length over here is about 5 centimeters. I'm going to say 5.07 centimeters. Okay. Make sure it makes sense with the problem. If the hypotenuse is 12, then this side should be smaller, right? So I think that's okay. These triangles are not going to be drawn to scale, so don't think that they're going to like make sense visually necessarily every time. But it does need to, the side lengths do need to be smaller than the hypotenuse, and they're probably not going to be like wildly different, right? Okay, so here we have another example. I want to find this side here. This is my reference angle, the 67-degree angle. So I need to find out which two sides I have so that I can decide if I want to use sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent. So 67 is across from this side, so this would be the opposite side. My hypotenuse is this long one, right? So this is the adjacent side. So which one uses opposite and adjacent? That would be tangent. So tangent of the angle, and the angle is 67 degrees, is equal to the opposite side, which is x, over the adjacent side, which is 14. So again, I need to get x by itself, so I'll multiply both sides by 14. Remember, it gets multiplied on the outside of the function. So 14 times tangent, I'm just putting this in my calculator, 67 is equal to 32.98. So that makes this side 32.98. You could round it off to 33, I suppose. And we have no units here, so we're just going to keep it as 32.98. Okay, so let's go ahead and try another one. We're just going to keep doing examples here. So again, here's my reference angle because that's the one I'm given. This is the adjacent side to that angle, and this is the hypotenuse. So adjacent and hypotenuse, remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so that's the one we want because it has those two sides that I need. So cosine of 18 equals x, the adjacent side, over the hypotenuse. So again, just multiply both sides by 17, and x equals 17 times the cosine. I'm just putting it in my calculator here. 17 times cosine of 18, and that is equal to 16.17. Okay, so this side right here would be 16.17. It is a little smaller than the hypotenuse, so that's a good sign. Okay, so here we're finding x. That's the hypotenuse here. This is the adjacent side to 51, so 51 is our reference angle. So again, adjacent and hypotenuse is cosine. So cosine of 51 degrees should equal 10 over x. Now notice this one looks a little different than the other examples that we did, right? X is now on the bottom instead of on the top. Now, because x is on the bottom, we need to get x out of the denominator. We don't want to know what like 1 over x or 10 over x is. We want to know what x is. So since 10 is divided by x, in order to undo divided by x, I would multiply both sides of the equation by x. So now I have x times the cosine of 51 equals 10. Okay, remember this cosine 51, I can't get rid of this 51 by cosine by dividing, right? Cosine 51 is grouped together, I guess, in a way. It's a function. We can't undo pieces of it by a different operation, okay? So I have this x here. I want it by itself on this side. Right now it's x times cosine 51. So to get rid of times cosine 51, I would divide both sides by cosine 51. So x is going to be equal to 10 divided by cosine of 51. Okay, so this is what you're putting in your calculator. 10 divided by cosine 51. Hit enter, and it should give you 15.89. So this side is 15.89. Okay. So again, be paying attention. If x is on the top, then we would just divide the bottom number. I'm sorry, we would just multiply both sides by the bottom number. If x is on the bottom, we have to multiply both sides by x to get it up out of the denominator, and then we have to divide cosine 51 away from x. So there's a little different method depending on which one you're looking for. Here again we're finding x, and x is here, so we don't need to worry about this one. That doesn't tell us any information, so we need to use this side because we know it, and this side because that's the one we want to know, and here's our reference angle. So it looks like x is our hypotenuse, and it looks like 6 is our opposite side. So opposite and hypotenuse, the function that uses that, it's not cosine, is sine. So sine of 30 degrees is equal to the opposite side over the hypotenuse. Again, x is in the denominator, so to get it up out of the denominator, I need to multiply both sides by x. So x times sine 30 equals 6. And then go ahead and divide both sides by sine 30. To undo x times sine 30, I divide both sides by sine 30. And then in my calculator, I just do 6 divided by sine 30. And that gives me 12. So x is equal to 12. Alright, go ahead and give some of these a try. Again, if you have questions, please email me. We can set up a Zoom if you need to, just anything you need to help you understand. But have a great day, guys, and we'll see you next time.